Okay, perfect. So thank you for connecting, even if there's just the three of us. So I'm Juan Felipe Reaña. I'm a PhD candidate in economics at the UBC, and today I'm really excited to share with you this joint work with Felipe Valencia Caicedo from UBC as well, that we called Collateral Damage: The Legacy of the Secret War in Laos. Let me start with the broad motivation of this paper. This is trying to understand or to study the long-term impacts of conflict on economic development. So even though we have plenty of anecdotal and empirical evidence on the negative short-term impacts of conflict for development, when it comes to the long run, what we find is that the evidence is actually quite mixed. And most of the literature can be basically categorized into basically two bins. One is basically we find no effects after 20 or 30 years after the conflict ended, or even this rhetorics about positive effects of conflict in the very long run. So just to give you a couple of examples, if you think about what happens in the case of Japan or Germany after World War II, we have these perfect stories of full recovery after the war ended, right? Or the typical and super famous paper by Miguel and Roland in the JDE that tells us that after the bombing of Vietnam, 40 years after, basically there are no differences between places that were heavily bombed versus those who were not. And if you think more in the big scope of things, when you look at state capacity literature, you say that some of the interstate wars require certain fiscal capacity to raise some money to keep the conflict going, right? So that state capacity that you create in the past affects the state capacity in the future and eventually economic development, right? So you observe like a positive effect after the conflict finishes in a very, very, very long run. And you can think also in this Malthusian mechanism. If conflict destroys capital and basically kills people, the marginal productivity of labor and capital is positive and increasing after the war finishes. So you expect growing rates in these places going up after the conflict, right? So this paper is going to be part of a new set of works that is trying to revise this literature on perfect post-war or post-conflict recovery using highly disaggregated data and updated methods, econometric methods to study this question. So two examples, one of my co-author, Felipe Valencia and Atud Prats, on the long-term impacts of the Spanish Civil War in Spain, and another paper by Leopoldo Ferguson, Ana María Ibáñez, and me on the long-term impacts of conflict in Colombia after the period of La Violencia in 1948. So what we find, and in general, this paper that I'm citing here, is negative effects of conflict 40 or 50 years after. And that goes against, let's say, what the literature have telling us so far in terms of the long-term effects. So what we're going to do in this paper in particular to answer this question of the long-term impacts of conflict and economic development is going to be zooming on Southeast Asia, and in particular in the Laos People's Democratic Republic, the country that I'm highlighting you here in green. That is today one of the poorest countries in the world, but also the most heavily bombed country in human history. So it's estimated that due to the US secret intervention in the country during the Vietnam War, the country received the estimated of one bomb every 8 minutes, non-stop for 9 years in terms of quantity, okay? And a natural question to ask in this context is whether or not conflict can be one of the causes of the underdevelopment in Laos, right? So the spoiler alert is that we find is actually, we believe that that's the case, but importantly for us is trying to identify towards the mechanism of transmission through which this conflict is affecting economic development today. So we're gonna be emphasizing in the paper the role of unexploited ordnance or UXOs, basically bombs that never explode or keep exploiting over the years, and the effects that these artifacts are having on human capital accumulation, settlement patterns, and labor market outcomes. In doing this emphasis in the UXO, we are part of recent literature trying to highlight the importance of these artifacts for economic development. Two papers that are important to highlight here, the demining of Mozambique or the demining of Colombia, that shows that once you remove these landmines, you unlocked significant levels of economic development and growth in these countries. And also how these artifacts could affect, for instance, agricultural land use and agricultural productivity. Okay, So this is a historical paper, so let me give you a bit of the historical background. So this intervention of the US in Laos is part of, occurs in the midst of two related conflicts, the Laotian Civil War and the Vietnam War. And both have the same let's say sides of conflict, but basically a group of people who are like supported by the communist forces and another group of people who are supported by anti-communist forces, or yes, and this in this type of conflict, what is happening is that the CIA start a covert operation to try to stop the advance of communists in Southeast Asia. So what they were trying to do was just trying to stop the move of supplies and troops from north of Vietnam here to the south of Vietnam through what was known today as the Ho Chi Minh Trail. That was a series of paths, bridges, and tunnels that go from north of Vietnam to south of Vietnam, crossing through Laos. And the logic of these operations that were secret at the time, not the Congress or the citizens in the US knew about this intervention, was to try to stop these guys from moving from the north to the south. And we have that this intervention basically ended up in more than 1.6 million recorded missions of bombing in the country, with around what we estimate today around 13 million cluster bombs. Okay, so in a nutshell, what we're going to show you in the paper today is this relationship that we have in a proxy of economic development, in this case NILETs, and the presence of these bombing events in the past. And here I'm basically overlapping the information on stable NILETs in 2013 with the bombing events from 1965 to 1973. And as you can see in just visually in the two pictures on the left and in the regression picture on the right, that is basically based on a bin scatter of different observations within these two maps, we're gonna finding a negative relationship between bombing and NILETs. Okay, and the promise that I try to do here is that we're gonna try to convince you that this relationship is actually causal, and that the mechanism of transmission between these two variables is basically the presence of these bombs that don't explode. Okay, so the Brigal strategy is going to go in 3 steps. In the first part of the paper, we're going to be dividing the country in a grid cell of 10 kilometers by 10 kilometers and running OLS and fixed effects specifications that mimic the relationship that I just showed you. In the second part, we're going to be addressing the fact that conflict is of course not random and the bombing is of course not random. So we're going to be exploiting an instrumental variable approach that exploits basically the asymmetries of information between both sides of the conflict, the communist and the non-communist forces. And in the third part of the paper, once we establish the causality of our results, we're going to look at the mechanism of transmission, highlighting the importance of UXO, and looking at individual level data based on census information, and do this typical differences analysis between being exposed or not to conflict and at different moments in your process of basically human capital accumulation. Okay. So in terms of data, we're going to be using the classified information from the US Department of Defense that have information on all these combat activities from 1965 to 1973, and 3 snapshots of NILETs today, basically 20, 30, and 40 years after the conflict ended. This information that we have comes from the usual sources, NASA and others. And in order to move beyond NILETs, we're going to be looking at more tangible economic outcomes from population censuses of 2005 and agricultural census of 2011. In terms of UXO accidents, we have a really detailed information on panel, basically a panel of all the accidents that have occurred in the country from 1950 to 2011 of people who are disabled or died because of these artifacts. Okay. So in terms of this baseline specification, we're going to be running super simple at the beginning, relating a measure of luminosity and a measure of bumps. Here, the unit of analysis is a grid cell. And we have basically running this regression for every year, 1993, 2003, and 2013, or pulling everything together and taking basically fixed effects. To give you a sense of how disaggregated the data is, here I'm showing you the country, the 2 levels of lower levels of administrative administrative divisions, and we're going to be using basically these small grid cells of 10 kilometers by 10 kilometers. In the middle panel, I'm showing you the the distribution of nightlights in 2013, and the hotspot graph of the bomb intensity in 1965. And as you can see, even visually, just the graphs, places that were heavily bombed are less lit today. Okay, so here I'm showing you the baseline specification across different controls and location control and geographical controls. But I want to draw your attention to column 7, that is the most demanding specification, in which we can observe that one standard deviation increase in the total amount of bombs is associated with a decrease of around 2.3% in terms of nightlights. And if you do like this back of the envelope type of calculation using the elasticity that maps from nightlights to GDP per capita, we find that this increase in bombing is associated with a fall of 9.3% in GDP per capita. So it's a sizable effect almost 40 years after the conflict ended.
Juan Felipe, a clarifying question, sorry.
Sure.
Well, I don't get the panel structure. Where is it coming from? If the bombs were like several decades ago, and
no, perfect.
No, you have a cross section of bombs, right? You have a cross section of bombs. So what is this panel?
Yeah, no, it's not a panel. It's a pooled OLS regression. So we have like a repeated cross section if you want. We observe nightlights at 1993, 2003, and 2013, and we can just pull everything. Look, it's more efficient, but we have also the results like let's say per year.
The treatment is a cross section.
Yeah.
So I mean, it doesn't make sense, right? Because you could have also yearly data on nighttime lights and do this pseudo panel, not for 3 observations, 3 cross sections, but for like 30 cross sections, right? So this is quite arbitrary.
It is. The only thing that we are doing here is.
But go ahead, sorry.
We are not using this for identification at all. What we are using here is just showing the correlations. We can do this, and I agree with you, using this luminosity for every year and just a cross section, nothing at the panel if you want. However, let me tell you, we're gonna use the exposure and this panel at the end of the paper when we exploit basically a cohort level analysis, a difference in differences analysis using the place of birth of these people who are exposed to violence. But I take your point. Here, I'm not using, let's say, a panel structure. That's why I say a pooled OLS regression. Okay, so the important thing here is understanding that, of course, this regression is not by any means, it could be interpreted causally at all. So what we need to understand now is try to assess what is the OLS bias here. We can be facing an underestimation of or the actual impact of conflict if the bombing were affecting key infrastructure for future development, if they were targeting roads, buildings, bridges, or paths that affect future economic outcomes, right? But also we can be overestimating the actual effect of war if these things were targeted basically isolated places. If the US was not targeting civil society, but just jungle, okay? Poorly or isolated places. So we have in the paper a lot of evidence that supports the fact that we are facing an underestimation of the actual effects because bombing was, of course, not random, but in any case was costly, right? So they are not like bombing everywhere like at random. They have certain targets that they want to destroy. So what we're going to do to address the potential endogeneity of conflict is we're going to be exploiting some informational asymmetries that occur during this period, in which basically not the CIA or not the communist side observed perfectly where the location of the enemy was. Okay, so we're going to be using as an instrument for bombing. Let me start for the second one, the distance to the US air bases that were established before 1960s, before the conflict started, and basically bases that are outside Laos, that were not part of the conflict itself. And we're going to be using this distance to predict bombing, and we believe that the distance is not correlated with economic outcomes within Laos. Also, we have other instruments, is basically using the distance to the Ho Chi Minh Trail based on these historical maps that tells us where the paths and the tunnels were. But reassuringly, both instruments are giving us basically the same quantitative and qualitative results. So here I'm showing you just the first stage of both instruments, basically the distance to the bases and the distance to the Ho Chi Minh Trail and the relationship with the intensity of bombing. Here we're using just to allow for heterogeneous effects in the instrument. We are having a quadratic nonlinear first stage, but the results are robust to using just linear or both instruments at the same time or individual. So here, let me show you the IV results. Consistent with this underestimation, once we control for the potential endogeneity of the bombing, we have bigger effects in the IV. And the number to take home is basically that one standard deviation increasing the amount of bombs deployed is associated with a decrease of around 10% in terms of luminosity. Okay, so the natural question is, okay, but this is just NILETs. Yeah, sure.
I apologize. This is still, I believe this is clarifying, and that's why I'm interrupting you. I still don't get why you have time fixed effects in those regressions.
Oh, no, it's okay. So there is a specific answer to that, is that every year that you have luminosity, the satellites are using different set of settings. So we can basically observing information from the night lights that is just coming from a specific shock of that year that they were taking the information on night lights. Here, I'm just going to emphasize, we are not saying that we are exploiting with like time variation in the exposure. Here we have just a correlation over time, bombs in the past, luminosity in the present, and the luminosity in the present is at 3 different years. Okay, if you don't like the time fixed effects, let's say, what you can say is it's not time fixed effect, call it a wave fixed effect, the wave of the luminosity information. It's just that we observe this proxy of economic development at different points in time. That's it. But we are not using this for identification. Here we are using just bombings in the past, luminosity in the present, and that's it. And the instrument is what we are using for identifying. Again, I can do this for each one of the years individually or everything pooled, but this is more efficient econometrically speaking, right? Okay, so when we look at more tangible economic outcomes, we're going to look at, in particular, information from the census at the village level. And we're going to try to see here is divide the sample of villages among those who are above or below the median of bombing intensity, and see what happens and how that correlates with the expenditure per capita in these villages and the incidence of poverty. And as you can see here, either in basically the graphs in the distribution or the regression analog of these images that I'm showing you here, places that were heavily bombed are experiencing just less not just less expenditures per capita, but a higher poverty rates in general. So it's not just nightlights, it also seems to be associated with this more tangible economic outcomes. Okay, so what is the mechanism of transmission that we believe is driving these results? Is the presence of this unexploited ordnance, basically bombs that were dropped in the past and immediately didn't exploit and start having a problem over the years. Just to give you a sense of what is happening here, let me show you parts of the pictures that we have there. Most of these cluster bombs are sticked in rice fields or even in roads, bombs that for different reasons didn't exploit. And what we're going to be using here is information from the agricultural census that tells us some assessment that the government has on the basically UXO contamination. So here I'm relating the intensity of bombing from the US data with the information that the Lao government has on agricultural and land contamination, agricultural contamination based on UXO. And as you can see, in the intensive and extensive margin, the relationship seems to hold, right? So here, more bombs are more, it's more likely that you have a contamination of UXOs, and that occurs in the extensive and intensive margin. But it would be a problem if you have contamination and people know exactly what it is, where these places are. But the problem is that this is also affecting people's life today. So there are more contamination of UXO is associated with more UXO accidents in this panel that we have on UXO accidents from 1950 to 2011. So here I'm showing you the fit for each decade in the intensity of bombing and the number of accidents that we observe every decade. And as you can see, there is a clear positive relationship between those. And in terms of levels, it started super high in 1960s, and it has been basically decreasing over the years, but still positive even in the 2000s, okay? So these bombs are still basically affecting people today. Now,
Felipe, last 5 minutes.
Perfect. So what we're gonna do now is saying, okay, this is affecting for sure. Disability would be the first outcome to look at. So here I'm doing exactly the same exercise, dividing the villages above and below the median of intensity of bombing and looking at disability as an outcome. And you can see places that with more bombs have a higher fraction of people with disabilities, but also these villages seems to be less dense in terms of population. And interestingly, and this is what we're going to be zooming now, is what happens in terms of literacy rates. We observed that places that were heavily bombed have today lower literacy rates. And this is to be systematic. So we're going to be zooming into the individual decision, basically information at the individual level. And in order to do that, we're going to be following a difference in difference specification, in which we use information from the micro level data in 2005, basically around 500,000 observations. And we're going to be trying to relate individual level outcomes, such as educational attainment and labor market outcomes, on the intensity of being exposed to conflict in the past, depending on the end of your cohort of birth. So here we are using the intensity of bombing interacted with a dummy variable that tells us if you were born in province P and belongs to a cohort birth K, and usually a specification difference. In difference, we have cohort fixed effects and province fixed effects. So these are basically the main results. We have the parallel trends, people who are too old to be affected by the conflict itself and the bombing, basically non-effects on terms of years of education. Here, the outcome is year of education. Sorry, I didn't say that. And people who are in their school years, we observe like a decrease in the number of years of education, but it's quite tiny. What is interesting for us and why we believe this is driven by the presence of these UXOs is that people who were born just after the conflict finishes, like 9 years after 1964, is for those who we observed. We observed the fall in years of schooling, and the magnitude is quite huge. It's around 0.2 years of schooling on an average of around 4. Okay, this also translates to less likely less likely to have a job, find an employment, but I'm going to skip that for the interest of time. But even if you find a job, what we find is that these guys are more engaged in agricultural type of activities and less in services. So we're going to be arguing that this slowed the process of structural transformation in the country, and not just that, basically this locked people where they were in the conflict. So here I have the same specification, but the outcome is long-term migration. If they move from the place of birth to a different city, and what we see is that there are basically, if you were born after before 1964, you're basically non-effects, no differential effects. But if you were born after the conflict, you are less likely to migrate, and that is basically consistent over time. Here, the average rate of migration is quite low. It's just 10% of the people move from the province that they were born, but still the effect is around 10%. Again, all our effects on human capital are concentrated in non-migrants, telling us that basically any policy that's trying to stop this should target in first people who were not able to migrate and basically overcome the shock of conflict. And that's basically it. So just to don't take more of your time, let me conclude. So this paper, what we do in this paper is basically using new and highly disaggregated data. We document the negative long-term impact of conflict on economic development using this proxy of NILATES. We show that it's robust to an instrumental variable estimation, which suggests a causal impact between these two. Bombing and NILATES. We show that this is not just in terms of NILATES, that also affects poverty rates and levels of consumption. And in terms of the mechanism of transmission, we highlight the presence of this unexploited ordinance and the effects that these artifacts are having on settlement patterns, human capital accumulation, and labor market outcomes. And we look at the interactions of migrations. We observe that this is basically concentrated in non-migrants. And more importantly, all the effects seems to be driven by these people who were basically locked in their country. So that basically would be it. Very happy to answer your questions and hear your comments. Yeah, thanks.
Excellent. Thanks a lot. I think you are perfect in terms of time. And so we will make the discussion at the end, I think. So,
Perfect.
Alexei, why don't you just take the stage?
Let me unmute myself first. All right, so thank you very much to the organizers for pushing together this panel and for including our paper in the program. My name is Alexei Makarian. I'm from the INAUDI Institute for Economics and Finance in Rome, and I'm a substitute teacher today for Vasily Korovkin, who is an assistant professor at CERGI in Prague. So unfortunately, he couldn't make it today. The project is titled Production Networks and War. So the motivation comes from one of the classical questions in political economy development that Juan already hinted at. What are the economic consequences of armed conflict? And of course, this literature is huge, but one of the downsides of that literature is that it mostly focuses on the direct exposure or the effects of the direct exposure of individuals and firms to violence, and the spillovers of conflict are understood much less. And why do we care about the spillovers of conflict? So first, at least as of 2016, more than 2.6 billion of people lived in countries with ongoing conflict, but at least 50 kilometers away from the violent events. And second, if spillovers of conflict turn out to be non-zero, then actually the traditional estimates of assessing the economic impact of conflict by comparing violent and non-violent areas, such as difference in differences framework or synergetic control framework, they may heavily underestimate the total economic cost of conflict. And especially one area in which there has been very little evidence so far is documented the spillovers of conflict on firms. And why is that? Because it's very difficult to obtain the high quality data on firms and trades. Typically, these kind of data sets at the micro level are available only for developed nations. And second, the issue is that typically in a conflict-ridden country, violence is spread around the country, and so cleanly identifying spillovers is often quite challenging. So in this literature, in this paper, we'll try to make progress on a few open questions in the literature. So the first one is whether there are any propagation effects of the conflict shock, and if so, by how much, and if difference in differences specification would underestimate the total impact of conflict. Second, another question that we'll try to make progress on is who wins and who loses in the rest of the country as a result of the war-induced change in the production network structure. I'll be more specific about that later. And the final open question is how quickly does the production network readjust? And on that, we'll try to make progress with the help of production networks model. So in this paper, we'll study one of the largest conflicts of the past decade, the 2014 Donbas War and the occupation of Crimea. So we argue that this conflict is especially suitable for the specific research question. Why? Because first of all, the violence was localized to Donbas area, and so the rest of the country was not exposed to the conflict or violence. And I will show you a map that kind of will make it clear. Second, it was a huge shock to the Ukrainian economy. Donbas and Crimea were together responsible for up to 18% of all Ukrainian GDP before the start of the conflict. So this conflict was heavily important. And then finally, in this context, we have access to this great data set on the universe of firm-to-firm railroad shipment from 2014 through 2016. And what it allows us to do is to track the production network evolution before and after the start of the conflict. This makes this data pretty unique, not only in the conflict literature, but also in the production networks literature more generally. And we are not too worried about the railroad shipment being railroad shipments, because railroads are the most important way of transporting freight within Ukraine, as you can see from this number. So let me preview our findings. So first, we provide evidence for what we call the ripple effect of conflict. And by the ripple effect of conflict, we mean that violence does not only affect firms in direct vicinity of the conflict, but it also it affects buyers and suppliers, and buyers and suppliers of the buyers and suppliers. And we find that if you take two firms located outside of the conflict area, but one of them had traded with the conflict area before the start of conflict, Then after the start of conflict, trade between those two firms outside of the start of conflict, but who are connected indirectly to the conflict areas, trade between those two firms goes down. We call it a second degree effect, and we show that it's negative and significant. That's the magnitude is about 1/3 of the first degree effect. And because there are so many of these second degree connections, and a huge difference in different specification, we actually underestimate the total economic impact of conflict on trade by about 67%. The second thing that we are doing here is that we are arguing that conflict does not only propagate through the production network, but also it alters the production network structure. In our case, 3 huge regions of the country were separated from the rest of the economy, and as a result, this has severe implications for the production network structure in the rest of the country. And as a result of that, some of the firms will become more central, some of them become less central, some of them will gain in terms of their relative network position, some of them will lose, relatively speaking. And we find that actually that matters even controlling for the ripple effects that I showed you before, that matters for firm sales. And finally, we use a production networks model to separate the contribution of 2 ways in which the network structure changes due to the conflict. So the first way is which we call network destruction, refers to the fact that the conflict cuts off firms located in the conflict areas. And the second mechanism, which we call network adjustment, refers to this process by which firms find new buyers and suppliers in the rest of the country after the shock hits. Importantly, we do that because not only that allows us to quantify this network adjustment channel, which actually compensates for about 2/3 of the destruction effect of the median revenue, but also by introducing this model, we're are able to say something about the aggregate changes and not only about the relative changes that different use typically get at. So we contribute to 2 strands of the literature. So the first one is the literature on conflict in firms. So this literature goes back to the contribution by Guidolino and Ferrara, but it also adds to the paper that we just wrapped up on the Russia-Ukraine conflict and the international trade between Russia and Ukraine. Relative to this literature, we estimate the ripple effects of conflict on trade. So we show how conflict, what kind of spillovers it have for the rest of the country, and also we document not only the ripple effects of conflict, but also of how conflict may affect the rest of the country by changing the production network structure exogenously. And of course, relative to our previous work, here we have production network data within the country, and the kind of questions we are answering is quite different. And so, of course, we also contribute to the literature on production networks. So this literature is mostly in macroeconomics, and it's mostly devoted to understanding how microeconomic shocks propagate and contribute to aggregate fluctuations. And in this strand of the literature, we studied the evolution of we were able to make progress empirically on studying the evolution of production networks after persistent shock. This combination of such a clean shock and such a high granularity of data is something that is missing from this literature, so we are hopefully will be able to contribute to this literature as well. So, and I'll tell you something about the background. I'll quickly talk about the data. Now, show you the results in order. So, as you may probably know, in February 2014, Russia conducted a covert military intervention to annex Crimea, and later it started supporting rebels in the east of the country. The annexation of Crimea went relatively peacefully, but the conflict in the east of Ukraine turned violent, and it's now officially classified as a war. It's now responsible for more than 13,000 casualties and more than 2 million displaced individuals. So this is the map of Ukraine. So you can see the Crimea at the bottom of the map. So this is kind of the Russian territory now, de facto. And then you have the Donbas area that is occupied by the rebels in the east of the country, in gray here. Of course, the red is the front line, and then the green territories are the parts of Donetsk and Lugansk Oblast that remained de facto part of Ukraine. And then the rest of the country is the rest of the country. But what you can see from this map is that there's this violence, this conflict is relatively localized, and the rest of the country was not affected by violence, but was not exposed to violence directly. And because of that, studying spillovers in this context is actually a great idea. Okay, so very quickly on the economy of these regions. So Donbas and Crimea were actually very important. So together they're responsible for up to 18% of Ukraine's GDP. Donbas especially was famous for its extractive industry, metallurgy, manufacturing. So together, these two oblasts called Donbas, that's why they're called Donbas. So they're responsible for 26% of all Ukrainian exports. So a hugely important region of Ukraine. Crimea, of course, was less important for manufacturing and for kind of upstream activities, upstream industries. But of course, it was also very big. So it's more than 2 million people, so it's important for demand, but also it hosted some agriculture, some tourism and so forth. So as a consequence of conflict and violence, manufacturing fell dramatically, and the occupied areas were practically cut off from the rest of the country in terms of transportation. So this is an example of what I'm talking about. So this plant was crucial for the Ukrainian economy, and it has suffered as a result of the context. So this is Donetsk metallurgical plant. It's a legendary plant opened in 1872 by John Hughes, who was a British entrepreneur and who was actually the founder of Donetsk. So I was actually amazed to kind of read about this. Before this plant, Donetsk was just a village. And in August 2014, after the start of conflict, this plant had to suspend its operations for the first time since the Second World War due to damaged railways. And it never really reopened in full since then. So, and definitely did not reopen during the time of my data up until 2016. So you can just imagine how the closure of elimination of such plants from the rest of the production network, what kind of effect it has on the rest of the country. And this is just one of the examples. I can give you many more. So we have data on the universe of railway shipments in Ukraine. These are firm-to-firm transactions. So we observed which firm sends to which firm, at what time, what kind of product they're sending, and what is the weight of the product they're sending. So because we know the IDs of the Ukrainian firms, we can merge the data with the accounting data for the Ukrainian firms in those years. So then this is the illustration of our data. So you can see Ukraine here, again, occupied areas in black. Then the lines here are the railways, and then the red dots are the railway stations. So of course, the railways are not in our data per se, but the stations here you see here is not some kind of the universe of all stations that we just plot, is the stations that we observe in our data. So you can see that the coverage of our data set is just the whole Ukraine. So this confirms the idea that we observe all of the data. And then importantly, consistent with the fact that Donbas was particularly important for upstream sectors of the economy, that heavily relied on railroads. You can see a dense cluster of railway stations in this area. And that sort of further, assuages the concern that maybe we are missing something using railway data. We think that in this particular case, actually, using railway data is not too bad of an approximation. Okay, so let me talk about the results. So first, we would like to present you some evidence on the ripple effects of conflict. So how do we do that? We estimate the following specification. It's a standard difference in difference specification in the spirit of the production network's literature. So here on the left-hand side, we have, importantly relatively to this production network literature, we are estimating not the effects on the aggregate outcomes, like aggregate sales of the firms, something like that. Here, we're actually looking at the trade link. And this is a kind of a contribution relative to what people have done before. So here we have looked at regress trade from firm I to firm J in a given month. We regress it on the firm pair fixed effects, and then the year-month fixed effects. And then we have two interactions. The first interaction is between the post-Crimea indicator, so post-conflict indicator, and whether one of the two firms in the link were located in Crimea Donbas. So then the other interaction is between the post-conflict indicator and whether one of the two firms had traded with someone in the conflict area before the start of conflict. So the beta 1 coefficient gives us an idea about the first degree of conflict, the first degree effect of conflict on trade, and the beta 2 coefficient gives us an idea about the second degree of conflict on trade. And of course, there are There are assumptions behind this strategy, of course, and I can discuss them. Of course, there's this parallel trends assumption, but there are some other some nuances. I don't have time to discuss them in detail right now. But in this table, we present the estimation results. We have 3 measures of trade intensity. So the first one is extensive margin, just an indicator of whether a firm sent anything to another firm in a given month. Then you have the logarithm of the total number of shipments that this firm sent to another firm in a given month. And then we have the logarithm of the total weight that the firm sent to another firm in a given month. And then, as you can see, the first degree effects of contact on trade are, of course, negative. That's not surprising. Of course, the magnitudes are just huge. But what's more surprising is that the second degree effects are negative as well. And the magnitudes are about 1/3. So why is it surprising? Because potentially the second degree of conflict, the second degree effect of conflict would even be positive. So why is that? Because if you can imagine a situation in which a firm is sourcing a product from 2 other firms, and then suppose that one of the firms is located in the conflict area and one of them is not. And then after the summer conflict, suppose that the demand doesn't change, and then one of the firms is basically removed from the production network. That firm has to source all of its input from the other firm. So basically, in this way, through the substitution effect, this beta 2 coefficient could potentially be positive. So the sign of this beta 2 coefficient depends on the complementarity, substitutability patterns in the economy. In this particular case, the coefficient is negative, but it's also in line with what other research has found. So in that sense, we are not too worried about external variability. Okay, so let me talk about the firm-level consequences of the network structure change. So the idea here is that the concentric shock may not only propagate through the production network, but in our case, 3 huge regions of the country were cut off from the rest of the economy. That means that that presents a huge exogenous change shock to the structure of the production network in the rest of the country. So what do we mean by that? And what do we mean by the conflict affecting firms for an exogenous change in the position of the firms? Let me give you a concrete example. So imagine this is a production network, and the nodes are the firms, and the edges are the trade connections between them. And suppose that, and let's take a look at firm D and C. So firm D and C here, they have, both of them have the same centrality independent of the measure. You can think about degree centrality, and then the degree centrality of both firms is 5, because they're connected with 5 other people. So then suppose that after the server conflict, firm B and G are disconnected, because firm B is in Crimea is disconnected, firm G is in Donbass is also disconnected. So what happens besides, suppose that there are no ripple effects, suppose that they control for them. Then firm D's relative centrality increased relative to firm C, because of the how the network is structured. And this shock was an unanticipated shock. So firms were not able to kind of really adjust to it beforehand. So because of that, and we also kind of shut down adjustment, endogenous adjustment afterwards. So what we, but then of course the firms can adjust and so forth. But what we do when we try to estimate the effect of log sales and profits on the change in centrality, is which we only use the change in centrality between this network and this network, because we're worried about reverse causality, potentially like more central firms becoming like more successful firms becoming more central. We're worried about that. So we use the exogenous change in centrality for each firm. We calculate centrality of each firm here. We calculate centrality of each firm here. We take the difference between the two, and then we use them in the difference specification. And then what we find then is firms that for exogenous reasons became more central as a result of the conflict, as a result of this war-induced change in the production network structure, they gained in terms of sales. And that effect is quite persistent and quite large. We also find some effects on firms on profits as well, but these effects are sort of short-term. We find also the effects on profit to cost ratio. So this effect is also short-term, and that's maybe potentially suggests that one of the mechanisms could be an increase in market power of the firms that became more central as a result. So just very quick takeaways. War-induced change in the production network matters for performance outside the violent areas. And one of the ways in which, one of the additional ways, one of the novel ways in which conflict may affect firms is through this, or any other shock, to be honest, is through this exogenous change to the production network structure.
Last 5 minutes.
Okay, fantastic. Okay, so then what do we do next? So let me talk about the model that allows us to disentangle basically the network destruction mechanism and the network adjustment mechanism. So we have a general behavior model with CES, constantly substitution, production function, and preferences. And what we use it for is that, in the end of the day, we use it for deriving the following equation. And that is a firm level Leontief equation. It's a firm level version of the typical Leontief equation that you normally see in the literature, which is like at the sector level. So you have tires, being used in the production of cars, and the production of rubber is used in the production of tires, something like that. So here it's all about firms as opposed to sectors. So you have production network matrix, which firm buys from who in the proportion of all of the inputs that the firm uses. Then you have the revenues of the total vectors of vector of total revenue, sorry about that, vector of total revenues of the firms. And then you have the outside demand of the railway network, this Xi parameter. And that parameter intuitively captures everything that is kind of not explained by our, everything that the revenue vectors that cannot be explained by our production network metrics. But it could contain final demand, but it could also contain some other firms that are outside of the railway network. So then you have alpha, which is the share of labor and other inputs. We calibrate it using Ukrainian data on firms. So then what we do next is very simple. We know from the data, we know the omega and we know the R for each year. So using that, we can calculate Xi for each year. And then what do we do? Okay, let me, before I go to contractuals, let me introduce this network that you already seen is the production network without adjustment. So it's post-conflict, but without adjustment. What it means is that we take the 2014 production network matrix and we just kill the firms that are located in the conflict areas. Just set their trade to zero with everybody. And then we estimate the revenue vectors under two counterfactual scenarios. So the first counterfactual scenario is we call it network destruction, and we fix Xi at the 2014 level, and then we change the production network matrix from the real production network matrix to this truncated one, where we kill the firms, but we do not allow other firms to adjust their links. And then the network adjustment effect is as follows. So we trace what happens to the revenue distribution when we fix Xi at the pre-conflict level, but then we move from the truncated matrix to the real observed matrix. And intuitively, it shows, it documents by how much the economy can rebalance as a result of just rewiring the network in the rest of the economy. And we believe that this quantification of that effect is very important for thinking about how economies react to shocks. And what we find is that here I will just present the median. In the paper, we also talk about the quantas, different quantas and distribution. So here at the baseline, we have 18 billion of hryvnias, whatever it means in dollars. Then and the network destruction effect is responsible for a drop of about 32% in the median of the revenue distribution. And then network adjustment effect compensates for about 2/3 of that fall. So just the fact that firms were able to find new connections and rewire their production network is responsible for just compensating the network destruction effect by 2/3. And then, of course, there is this outside demand shock, which is we estimated at about -16% at the median. And then the total change is the rough sum of these two columns, columns 3 and 4. And so this is the result. I can talk more about quantas and dynamics, but I'm running out of time anyway. So just to wrap up, with this section is that we find that the war-induced network destruction leads to about 32% in median revenue, ceteris paribus, and that the endogenous readjustment mitigates about 2/3 of the network destruction at the median. So to conclude, production networks are ever more important and complex. Economies are very vulnerable to shocks to connectivity. That could be conflict, that could be any other big shock. So for instance, severe quarantine restrictions during COVID-19, that could be another example that you may think about. And in the context of the Donbas war, we find that the ripple effects of conflict on firm trade are very large. Ignoring them is wrong. And then second, we find that firms that exogenously gain essentiality as a result of the change in the production network for reasons outside the firm's control actually leads to firms increase in their sales and profits. And then importantly, the network adjustment mitigates about 2/3 of the network shrinkage effect. So we believe that these results inform not only the production, the conflict literature, but also just the production networks literature more generally. And yeah, thank you very much for listening.
Thanks, Alexei. So I'm just jumping to my talk, and then we will discuss we will have joint discussion. Try to share my screen.
Do you want us to remind you the time or something?
That would be great. Do you see my screen?
Yes.
Okay. So in this paper, I study how violent environment affects capability of industrial development, and basically broad motivation is that globalization facilitates trades, expands markets, and this is mostly fantastic, but it also expands markets that we would like to get rid of or limit, such as the illicit drug markets. And drug trafficking is especially a major problem for the developing world. And by definition, developing world has weaker institutions, hence more prone to corruption. At the same time, faces lucrative demand coming from the developed world. And adds additional challenge to that, dealing with this problem. And often drug trafficking plays a central role in creating violence and conflict in cities where economic activities are concentrated. More than 80% of world GDP actually generated in cities. And we also know from the recent literature that there are large income disparities across countries, but also large income disparities within countries across regions that cannot be explained by observed differences in production factors such as human capital. And these income differences are especially strong in Latin America, where also violence and conflict in urban areas are important. So then whether violence and conflict afflicted environment can serve as barriers to economic development, potentially, and this could happen via, for example, slowing down or preventing efficient reallocation of resources across heterogeneously productive units, or it could also happen via distorting incentive mechanisms and affecting participation decisions of economic agents. So basically, homicide rate in Mexican city Juarez in 2010 was 283. In comparison to neighboring El Paso in Texas, there was 0.8 homicide was recorded per 100,000 inhabitants in the same year. So the distance between these two cities is only a few miles, but the levels of violence are orders of magnitudes apart. So the question is basically, does it matter? So does it matter for firms? Does it matter for the way businesses are conducted? Or otherwise, how do firms and workers cope with this violent environment? My context is Mexico because this picture shows why recently Mexico has experienced dramatic escalation of criminal violence due to the Mexican drug war. And just to give you a quick perspective, this shows the monthly homicide numbers. And in 2010, total number of homicides was about 26,000. And this is more than 3 times many killings as happened in that year in Iraq and Afghanistan combined. So it was basically a warlike, violent environment, and it happened not homogeneously. This escalation of violence didn't kind of affected the country homogeneously, and this shows the evolution of this escalation of violence measured as homicide rate across metropolitan areas in Mexico. And you see that in 2007, there are not many metropolitan areas with high level of criminal violence, but that scene changes quickly by 2010. So my paper builds on the earlier study that shows causally the reasons of this escalation of violence, and tells us, this literature tells us that the main reason for this sudden escalation of violence was simply the government's change in drug enforcement policy, Mexican government's adoption of kingpin strategy. And basically this strategy means that getting rid of these important key people for among drug cartels and directly targeting these leaders with direct confrontations with military power. So this strategy was successful initially in terms of getting rid of important leaders of drug cartels, but quickly after led to power vacuum and fights across drug cartels, as well as different factions within drug cartels to capture these strategic positions and strategic drug trafficking routes. Contributing factor to that was what was happening at the time in Colombia, where cocaine supply comes from, where cocaine comes from. At the time, Colombia was employing very effective drug enforcement policies as well, and that led to a significant decline in cocaine supply over this same period. And at this decline in cocaine supply significantly increased the cocaine prices. So while this was happening, while power vacuum was happening in Mexico, at the same time, the prices of cocaine, as a result, the bands to be captured by obtaining these leadership positions was increasing, intensifying this violence in the country. So what I do in this paper, I study how this violent environment affects firms and industry development, and whether certain firms are more resilient to violence than others, hence whether we can see violence something that impact resource reallocation. And to do that, I look for the causal evidence and utilize this quasi-natural variation, spatio-temporal quasi-natural variation in violence due to this drug war, and I construct my instrument based on these triggers of drug war to be able to isolate this quasi-natural variation, and employ plant-level panel data covering all of Mexico over the period from 2005 to 2010 to understand the causal impact of violent environment on manufacturing firms. So very quickly with this short talk, what I find that drug war violence significantly deters development of domestic industrial capability, and the results shows substantial heterogeneity both within firms and across firms. And studying this, exploring this heterogeneity points towards two important channels through which violence affects firms. One is that violence directly impacts firms via the decline in demand, but the more interesting channel that violence also affects firms via its effect on the labor market. So the results shows that labor supply channel is an important channel through which these firms are affected. At the end, results also show substantial inequality consequences of this violent episode in Mexico. So in terms of data, I use plant level survey, monthly plant level survey covering all of Mexico. That covers, this survey covers 90% of the nationwide manufacturing value added, and the average plant employs 240 people and produces 3 varieties. So the survey is designed as such that for each product, the survey starts surveying the plants from top, from big towards the smaller plants until it covers at least 90% of the value added within that product. As a result, bias towards bigger plants, and I will show you that the smaller plants are most affected, so you can see these results as the lower bound of the real effect. I enriched the data with this another survey that gives more detail in terms of the plants' technological and organizational capabilities and the sales distribution. This survey is not annual, but this information is going to be used in my heterogeneity analysis, explored as the initial characteristics of plants. So my spatial unit of analysis will be metropolitan areas, which will be the local labor market, basically, as defined as an employment core, and the surrounding areas that have strong commuting ties to the core. And this shows the type of variation underlying my data by showing you the homicide evolution of the monthly homicide rate, annualized monthly homicide rate across selected cities with similar populations such as Juarez and Leon, or Chihuahua and Saltillo. So this is kind of the showing the type of escalation of violence underlying this data. So to get first the broad patterns of the understand the broad patterns in the data, I first classify looking at the escalation of violence, basically by looking at the pre and post-shock number and the rate of homicides across metropolitan areas. I classify metropolitan areas that will be facing strong violence during the drug war. That gives me especially six metropolitan areas that will be exposed to this drug war, classifying them as the high intensity drug war metros, looking at the plant level characteristics across these areas before the shock. And I see that these plants are similarly have similar characteristics in terms of size or labor productivity as measured by output per hours worked, but also there are some differences, such as the plants located in exposed areas are more capital intensive. At the same time, they are more export oriented, and this is likely to be driven by that there are important border areas are important for exporting activities in Mexico, and these areas were at the same time located on strategic drug trafficking routes. So looking at industry distribution across these regions again shows that that industries are similarly distributed across these exposed and non-exposed metropolitan areas, and the industry distribution kind of more or less reflect overall Mexican industrial competitive structure. So in terms of my empirical strategy, so I relate the plant level characteristics. Plant, just going with the subscripts here. Here is the plant I, located in industry K, and in metropolitan area J, and time T. So I have both monthly and annual analysis. I will just show you the annual analysis here. And the violence is measured by the homicide rate. I take the logarithm and focus on the elasticity of the plant level outcome with respect to violence. and the control for the unobservable characteristics across plants as well as across metropolitan areas. I control for plant fixed effects. And during the time period, there are important aggregate shocks, such as the financial crisis, such as the important trade shocks. So to get rid of these confounding factors, I include 5-digit industry by time fixed effects, very detailed industry, to make sure that these results are not influenced by such factors. Also, I control for metropolitan area level pre-trans in the homicide rate, as well as potentially strategically important sectors, time varying sectors such as the crop production or oil extraction sectors, as these sectors may affect the opportunity cost of crime, or increase or decrease the rent opportunities and affect crime. So obviously, homicide rate is going to be endogenous to economic activities, sociological structure of metropolitan areas. So to focus on this quasi-natural variation because of the drug war, I kind of create an instrument that is based on these triggers of the drug war. Simply, the kingpin strategies. The most important policy tool was the military confrontations, and not all states collaborated with this federal army operations in 2007. So they, with the just after Felipe Calderon's election, states were voted for these collaborations, and some states said yes, and some states said no. Looking at those states that said yes to this military collaborations, we see that these states are located at the major hubs and the ports of the drug trafficking routes, basically. You see that, there are two important drug trafficking routes, one coming from the Andean region, one comes towards this area, and then one comes towards this area. And you see also from the Caribbean link comes to the important ports over there. And this will give me the spatial variation for the escalation of variance. And the second variation, partial second variation, time-wise variation, comes from what was happening in Colombia. Basically, the strength of the drug enforcement policies was influential in decreasing the cocaine supply there. And then to measure that strength of drug enforcement policies in Colombia, I used the amount of cocaine seized in Colombia, normalized by the total coca cultivated land, to get an additional time variation. And my instrument basically takes this form, the spatial variation from the selected states interacted with the Calderon's timing, presidency, and as well as the that takes one on and after year 2007, and interacted with this evolution of cocaine seized coming from Colombia. So the results shows that looking at the employment effect first, elasticity of plant level employment with respect to violence, OLS results show significant impact, but isolating this plausible exogenous increase in violence gives a bigger magnitude for it, indicating potentially confounding factor that are working both pro-criminal activities and manufacturing activities. And the instrumentation, the instrument is strongly correlated with the homicide rate, and at the same time, the strength of the instrumentation is good, given by this F-test. And so in the third column, I include these time-varying metropolitan area level strategic sector sizes, such as the crop production or oil extraction, and these basically have no effect on the results, showing that the instrumentation is doing a good job. So for potential heterogeneity concerns, then for the rest of the results, I don't include them. And again, to get rid of and somehow to remove any doubt regarding the potential confounding effect coming from the different trade shocks as well as financial crisis in the US, I include product by year fixed effects, killing all these shocks that can vary by product, and the results are still not affected and showing robust results and telling us that doubling the homicide rate in the metropolitan area causes by about 5% decline in plant level employment. So overall manufacturing activities extensively impacted with a significant decline in value of output, and the output decline is on average stronger as expected and natural in comparison to employment decline. And the value of output decreases driven by volume of output. And we also see that this is not just temporary in the sense that the product scope is also decreases significantly. And as plants downsize, output per hours worked also decreases together with the utilization of fixed capital of these plants, and potentially pointing out to work disruptions impact of violence. So exporting activities in general not significantly impacted. This shows just the 0-1 dummy, whether exporting affected by increased violence, and the additional analysis shows that export revenues are also not disproportionately impacted, and just the opposite. I will show you later on that diversification caused by export actually helps these plants to survive out of this violent environment. So
last 5 minutes.
More interesting results coming when we look at the heterogeneity, and this shows the within plant heterogeneity in the results. This shows the elasticity of plant level employment depending on the type of employment with respect to violence. And here on the left-hand side, employment is measured in terms of number of employees, and the right-hand side in terms of hours worked. We see strong heterogeneity in terms of the type of labor is affected. There is substantial decline in blue-collar employment. When we look at the white-collar or non-production employment, there is actually a positive effect. And then this considers the all type of workers, and if this is somehow driven by demand effect on firms or labor demand cause effect, then we should see this impact is stronger among temporary workers or hours worked, but we see both number of employees and the hours worked decreases quite similarly. And when I focus on only payroll workers, the type of workers that are costly to fire, we see that the impact actually stronger, not less, and additional evidence that this is not really purely demand-driven impact. So, but coming from the labor supply changes. And when we look at the payroll workers, we also see that the positive effect on white-collar workers becomes also negative, indicating that the positive effect coming from the temporary white-collar workers margin. So what is happening? This indicates that something is happening in the labor supply, that the violence is potentially changes the reservation wages of workers and potentially affecting labor force participation of workers. And then to confirm this hypothesis, I look at the wages, and the wages, average wages at the plant level shows no effect. But again, when we look at the differential impact, we see huge heterogeneity, that blue-collar workers' wages increases at the plant level and significantly, and white-collar workers' wages significantly decreases. So that is additional confirmation that labor supply affects firms rather than vice versa, rather than this is purely driven by violence-induced demand shock. that potentially especially the lower end of the wage distribution, workers located in these lower end of the wage distribution drop the labor market, probably because they are facing these difficulties in commuting and facing this additional risk, and that causes of reservation wage to go up. So if this is the case, if this is driven by the participation margin and increased reservation wages, because these lower wage workers are more exposed to this type of shocks, then we should see that this employment decline is concentrated on low wage firms and firms intensive in female labor also, because female labor have higher elasticity of labor market participation in comparison to male workers. There's an alternative channel through which labor supply thing would work, and that is the expansion of illegal sector that may be also increasing wages. But in that case, we should expect these wages as male brutal force wages should increase, and we should then see that this more susceptible firms should be the ones that are intensive in male labor. And this is just an occupation-wide picture showing that, this is not plant-level analysis, showing that indeed, when we look at nationwide, blue-collar unskilled workers are most exposed to this dangerous environment. I will just keep and concentrate on the plant-level results. And this shows the, cross-firm heterogeneity, and looking at the employment, elasticity of employment with respect to violence, depending on different characteristics of plants. And the first graph shows the employment decline is concentrated on the low wage plants, and actually high wage plants are not much affected in terms of employment reduction of violence. And the second graph shows that most of the employment reduction again is happening among plants with high share of female workers rather than high share of male workers. Pardon me?
1 minute.
1 minute? Okay, that confirms that this is the labor supply channel driven by participation margin, that low wage workers and especially female workers are dropping out of the labor market, affecting firms. And additional evidence comes from that, especially focusing on the classifying plans depending on how much they pay for the unskilled female workers, shows that especially low wage female worker plans experiencing this reduction in employment. And so focusing on average wage among unskilled female workers, high wage plans basically are not impacted by this. And I did the similar analysis by focusing on the average wage among unskilled male workers, and again the results show similar reductions, meaning that the expansion of illegal sector is not the driver, but the participation margin is that is the driver. 30 seconds for the second channel, that the violence induces decline in demand, and this is the first order effect is on the output here, and the output reduction is concentrated on non-exporters, domestic plants, and non-importers. And the reason for this is that the exporters are more diversified, and looking at the geographical distribution of these plants' sales, I also constructed an entropy measures and classify plants depending of this the intensity of their sales diversification, and I find that output reduction again is concentrated on not diversified plants, and similarly for the inputs diversification. So these locally focused local selling and sourcing plants experiences reduction in output more strongly. And I also showed that these two channels are working independently. So I won't have much time. I will just conclude here. And that these intensive margin channels also work similarly when we focus on the extensive margin plant exit. Just to conclude, so studying the impact of this exogenous, plausible exogenous variation, the increase in violence due to the Mexican drug war in Mexico, I show that violent environment indeed causes significant drop among plant level output, capacity usage, product scope, and employment. And both of these effects are visible and significant both at the intensive margin, but also at the extensive margin in terms of the plant exits. And over the time period, the manufacturing employment decreases close to by about 7%, about like 500,000 people. And the elasticity measures and using the back of the envelope type of calculation shows that this violent episode over this time period between 2005 and 2010 accounts for about 70% of this decline in manufacturing employment. And I show that, firms are obliquely impacted via this labor market margin, that rather than most of these shocks, that the shocks first hits firms and the firms re-optimize their labor demand, and that has an impact on labor market. This time, violence directly affects the labor market and causes labor supply changes, and through that labor supply, we see impact on firms. But cross-firm heterogeneity also shows that there is significant resource allocation as a result from locally sourcing and locally supplying firms towards bigger, more capital-intensive and diversified plants. And while the output, short-term output reductions because of this type of resource reallocation may not be big, but still these will have important dynamic implications deterring developing domestic industrial capabilities. Thank you.
Okay, thank you.
So I have a question to Juan. Is that okay? So I think, yeah, my point is kind of similar to what the other Juan was saying. Sorry, is that yeah, I find this counterintuitive that the agriculture actually seems to be kind of on the rise, because from the Gimanian papers, it seems like the agriculture is the thing that actually goes up after the Gimanian efforts. So when there are mines, it's kind of harder to, cultivate the land, put the cows and kind of let them eat the grass, right? So I'm just curious kind of what you think about that, and what do you think is going on?
Yeah, so there are like two stories there. One is yes, this definitely could have affected agricultural productivity in general, right? They need to do it differently now. So there is this argument out there about like they are probably more careful about the cultivation process and things. So what we are doing for that angle is that we're looking at, in the agricultural census, if there are like changes in productivity in places that are heavily contaminated. But we haven't found much actually. So what we believe is that what is happening is like more in the terms of the land that you have access to, not in terms of how productive it is, but the type of land that you have. So we are looking at different effects in terms of the type of land, and we are looking like we're finding like interesting results there. But I'm not confident to tell you exactly in terms of productivity what is going on. Yeah, Yeah, those. Yeah, I'm not sure if that was what you were asking, but yeah, I mean, we have been looking at that.
So the bottom line, like the bottom line is that you're trying, like right now you're working on trying to estimate the agricultural productivity as well, like effects, and you haven't moved around much of that. That's kind of the bottom line. And the other question they had is, I mean, it's very minor, but so I was thinking that maybe just from the patterns that you saw on the maps, I haven't actually checked the real maps of Laos. I should check this right now. But I was wondering, is it kind of only about ruggedness, but maybe it's also about just the woods? Maybe, you know, the fighting was going on more like in the areas with the kind of more so there is this indigeneity, right? So you're trying to control for it, like in the OLS, and one of the variables that you have there is ruggedness. I think is nice, but I think you could also do the woods, right? Because I think you, like from the satellite, you could see like where the woods are, like jungles or whatever, and yes, that could be another control. I don't think it's a major addition to this story because it's still OLS. It's kind of it's still biased. So.
Yeah. The only issue is that the roads is actually a bad control in that scenario because bombing destroyed part of the roads, right?
Wood. Not
wood.
Yeah.
Wood coverage.
Yeah.
Oh yeah. That's actually good, like land coverage. Yeah. We can actually try to control for that. Yes, for sure. Yeah. Thanks.
So when you look at the heterogeneity, do you look at the suitability of the land towards certain agricultural products, like, for example, export crops, or?
Yeah. So we are not doing that right now, but we're definitely finding like different types of land are driving the results. So it's more likely that the bombs are exploiting in places where the land was like more like harder, let's say. So actually we find something in terms of the type of land, but not in the type of agriculture that has been used. So in your case, if it's exportable or something like that, we haven't looked at that, but actually it's a good point. We can look at that. Yeah.
And Alexei, I was wondering about the water transportation, whether you focus on the railroad road network, and I think and these are the industrial locations you describe, but don't they also transport via river and the sea, or how is it?
Yeah, actually, from what I understand, it's either railroads or regular roads. That's it. But at the same time, regular roads are quite poor in Ukraine. So I actually, for the sake of time, I hope I've hidden that slide, but I have the slide where I have the ranking of the roads relative of Ukrainian roads relative to kind of other roads in other countries, and Ukraine is always at the bottom of the world ranking. But in railroads, Ukraine is at the top because railroads are great. It's one of the longest networks. It's very nice. It's kind of the legacy of the Soviet Union, in a sense.
And
the water is not very well.
I see. Do you then, similar questions, do you then explore the heterogeneity regarding maybe the transportation costs of?
We have the heterogeneity by industry. So we have heterogeneity by industry. We don't do it like by the transportation cost, but because we don't observe much in the heterogeneity by industry, there is some heterogeneity, but it's not dramatic. So it's not going from 0 to negative.
But then you say this is important for mining and that type of industry.
Exactly. No, my railroads are more important for mining and for upstream sectors. And that's why I think our argument is that because of that reliance on, and because our focus on Donbass, reliance on the railway transportation network is not too much of an approximation. Still, there is this question that we might not observe some transactions, but hopefully, like in the first part, it's not like, given that we don't observe much of the heterogeneity by industry, we think that it's not too much of a problem either. So, but it's a, yeah, it's a very good,
this
very
is
good
a,
point.
you know, really super nice data. I mean, very,
Yeah,
very
thank you.
nice.
Yeah.
Very nice.
I agree. Yes. But actually, in the Mexican data, do you observe anything about kind of who are their partners?
No,
who they
no,
source
that
the
would have
inputs
been
from,
super
or-
cool. I completely ignored that type of, you know, spillovers, and then, you know, I can cite yours and showing that the effect would have been bigger.
Exactly.
Exactly right. But no, I mean, I don't see the firm-to-firm relationship. And then since I already have too many results in the paper, I don't want to kind of add input, you know,
Yeah, of course,
kind of using the input-output linkages and stuff.
Yeah, no, I'm just trying. Yeah, it's more of a question like to understand the data, because yeah, no, this is kind of the thing that is rare to observe in the surveys and who they source the inputs from. Sometimes you observe this, sometimes you don't. I was curious about the Mexican.
Yeah.
I'm so sorry. I have to apologize. I entered a call that was super important. I'm so sorry. If you were talking to me and I was not there, sorry.
By the way, I realized also I was super over time. I'm so sorry. I didn't realize. So
it's
sorry
okay.
about that.
No, it's fine. It's fine. So that was really interesting papers. Probably I was just gonna email you with my comments. I'm so sorry about that. Yep. So
No
have a good day.
Juan, are you in the market this year or no? Juan, are you on the market this year or no?
Yeah, I'm on the market.
Yeah,
Good luck.
Best of luck.
But I think you don't need good luck.